going to test for the chi-square test for the independence. So chi-square test of the independence is actually looking for the association. Okay. The last test that we need to understand is actually test of independence. So it's actually measure association between x and y. What is your x? X is factor, and then y is outcome. And x also, and our x and y must be categorical. Make sure you done that one. It's no longer testing the differences, but is testing the association, or sometimes they call it as the relationship. But I'm going to do like this because I don't like this word. But maybe your supervisor like to use that word, then okay, I must be redo. So that's why the test association between the x, which is the factor, and then the y, which is the outcome. Okay, remember, your x is the factor and y is the outcome. So what is our x? So our x will be, let's say, our x will be gender. And then our outcome will be level of knowledge. Okay. Particularly because the gender have no significant difference in terms of the knowledge, and the gender also shows no significant distribution. So I may no longer input the gender. I'm going to use the test of working experience. You see, when you conduct any analysis, the most insignificant data or the most insignificant judgmental hypothetical variables, you might want to exclude them from the further analysis. That is the trick. When you run the bivariate analysis just now to make a comparison, okay, this one have no differences, then no need to run for the correlation. No need to run for the association test. That is why we have to do the univariate analysis, bivariate analysis, then we go to the multivariate analysis. That is the way you are doing things lah. Okay, in this example, I'm going to use working experience, which is 1 and 2, which is ada working experience ke tak. And then we have the null. So the null will be changed as follows. You must remember, when you conduct the chi-square, you must ask yourself, this chi-square is what kind of chi-square? Chi-square of what? You must ask. It's either goodness of it, which is test differences, or you are talking about test of independence. Okay, if I can recall, some of my students call it as the ujian menguji darjah kebebasan. Tapi dia orang tak cakap kebebasan, dan dia orang kata ujian menguji darjah kemerdekaan. Sebab Independence Day. So the truth is actually the relatedness. So the null will be IV independent towards DV. Means what? In the real term, or in the real nomenclature of the people will say that factor is not associated with the outcome. Okay, and then our alternative will be IV dependent towards or to DV, which is factor is associated with the outcome. This is still statistical word. So to write the proper word, you will have to do something like this. Okay, there is no what? There is no significant association between factor, which is our factor here is working experience, and level of knowledge. Level of knowledge will be our outcome. Alright. And then what is our alternative? There will be vice versa lah, which is there is significant. There is significant association between factor, which is working experience, and level of knowledge, which is outcome. Level 2 is same. Chi-square value need to be calculated differently, and then the p-values also need to be identified, and then you have to make a decision. And this one is the big change or the big alterations that you must understand. When you reject the null hypothesis, then you will make a conclusion like this. There is a significant association between factor and outcome. What is our factor? What is our outcome? Please explain it in your usage manual lah. I'm just going to say it as a factor and outcome so that you can use these particular words for your particular study lah. And if you fail to reject your null hypothesis, there is no significant association between factors and outcome. In this particular case, your factor will be your working experience, and then your outcome will be your level of knowledge. Level of knowledge being defined as high levels or low levels. Level of knowledge. Okay, to do this one, you have to construct what we call it as the cross tabulation. Cross tabulation is what? Cross tab. Have you heard about cross tab? Maybe you heard about this before, but now I want to show you how to do it. Okay. The first step, go to analyze descriptive statistic across a tab. Apa dia? Analyze descriptive statistic across tab. Cross tab. So this cross-tabbing formulation or cross-tabbing idea is actually want to measure the association, the relatedness between the row and column of that 2x2 table. If you can see it over there, is LH, LM. I mean M and non-M. LH is high and low knowledge, and then between the experience and non-experience, because we got these two variables, right? Go to the cross-tab, and then you remember one thing: row must always be your vector. Row must always be your factor. Row must always be your factor. Row must always be your factor. Row must always your factor. Row is your factor. And then your column is your outcome. Usually like that in medical and health science is something like that. If you are in the social science one, also I think is similar. Your row should be your factor and your column should be your outcome. Okay, in this case, what is my row? Working experience, right? Working experience should be our row. And then what is our column? Level of knowledge, right? Which is y.cat. Why I did not choose y.total? And if you choose y.total is wrong. Because this one is cross-tabulation. We need the categorical data. That's why we need the y.cat despite of y.total. We must have the IV and DV in the numeric count data. That means how many observed of this value and that value. In this case, high value and low value has been defined under the y.cat. So insert the y.cat inside the column. Have you done that one? Very good. And then go to the statistics. Please request following items. The first one, you can request for the square. Apa tu? Square, And then you can also request for the contingency coefficient pi and Kramer's V. You can request this one. And then another one that is much more favorite by all of our epidemiologists, medical officer in the public health and whatsoever, they always request for the risk. This one. They also request for the risk. So the SPSS will give you the cohort, I mean the RR, relative risk, and also the OR, odds ratio risk. You want to know more about odds ratio and relative risk? You have to learn about the epidemiological research. I can talk with you later on. If you want, just let me know. I can make a video for you and then you watch it nicely. If you have a question, you ask. If I can answer, I answer. If I cannot answer, I will answer also. Okay, and then go to the continue. And then go to the cells. And then in the percentage here, you tick for the column. You can tick everything actually, but this is the most appropriate way of doing things and the most prominent data output that I want to synthesize. And then the count here, you also can tick for the expected. Because I want to show you something on the, what is this? Chi-square. Remember, chi-square got one assumption. Your expected count cannot be less than 20%, sorry, expected count cannot be less than 5 more than 20%. What does that mean? I will show you after this. Okay, continue. And then you can hit the paste button or OK straight away. And automatically the SPSS are going to give you the output something like this. So this is your output, right? So the first one, low knowledge, high knowledge. Yes dengan no. Can you see this one? Yes. No. Okay, never mind. I'm going to export it so that we can zoom it together and synthesize the output more efficiently. Okay, so let us open it and make some interpretation out of it. Okay, this is my output of the SPSS file. Okay, so working experience, low and high knowledge. You see this one? 16, 7, count 5, 3. The first one, I said just now, the assumption will be the expected count cannot be less than 5 more than 20%. Expected count more less than 5? This one not less than 5, right? Expected count not less than 5. This one less than 5? Not less than 5. This one less than 5? Not less than 5. This one less than 5? Less than 5. Therefore, one cell less than 5. How many cells you get here? 1, 2, 3, 4. 1 over 4 times by 100. You got how many percentage? 25%. So can you use this Pearson chi-square? You cannot use Pearson chi-square. You can use alternative statistics here. That's why under the chi-square table here, it's already indicated. One cell, 25% have expected count less than 5. Means what? One cell counting the expected count less than 5, which is this one, 2.6, right? That's why it's violated the usage of the Pearson chi-square. Therefore, you cannot use the Pearson chi-square. You might want to use the alternative. Which one? If your Pearson chi-square is no longer applicable, you might want to consider these two statistics. The first one, after the chi-square cannot be used, is the Fisher exact. If the Fisher exact is not available, you are going to be used the likelihood ratio. If the likelihood ratio is not available, you can use the linear by linear association. That is the steps. Usually, we stop at the here. When the Pearson chi-square cannot be used, Fisher exact automatically being calculated for us, and then we can interpret according to the Fisher exact test straight away. But sometimes Fisher exact test also cannot be computed, and therefore you go to the likelihood ratio. So what you want to extract? This value, this is the value, this is the chi value, this is likelihood ratio value, this is the asymptomatic significance, which is more than 0.05. This is also more than 0.05. So that means you are rejecting or fail to reject your null hypothesis. In this case, which value you want to take? You take this one. Why? Because the value of the chi-square cannot be taken out. Why? Sebab apa? Sebab dia violated. And then you are talking about this one. 7.15. 7.15. And therefore, I would like to ask you whether you want to reject or fail to reject this null hypothesis. Fail to reject your null hypothesis. So if you fail to reject your null hypothesis, then you are making a conclusion there is a significant association or there is no significant association. Very good. There is no significant association between the factor and the outcome, which is this particular factor talking about what? Working experience. So that's mean whether you have working experience or not working experience is no longer one of the factors that influencing your level of knowledge to be high or low. It does not bother about that. Agree? Understand? If you scroll down, we can see the symmetric measures. The symmetric measures here also indicate the same assumption and same testing. What is this testing? Okay. Remember, before this, do you learn about R? What is R? Correlation coefficient, right? R indicate what? Strength and direction. Actually, pi, Kramer's-V, contingency coefficient, also similarly being interpreted like R. But remember, this one is called pseudo R. Pseudo. So in this value, if you can see here, 0.06 means that less than 0.2. What does that mean? Negligible. That means the association is can be considered not exist. You know, the association, the relationship, the relatedness, the kebersandaran is not there between the working experience and also level of knowledge. So, if you are epidemiologists and if you are statistical people who are looking into the risk factor based on the odds ratio or cohort, then you might want to interpret based on the risk estimate that already being produced by the SPSS down here. If you want to know more, I will explain later on. But enough for now. I would like you to conduct yourself for the other factors. Can you do that?